Alright, Bismillah. So here's a typical limiting reactant problem. In these problems, they give you reactants on the left hand side and the products, and they give you two of these reactants and they tell you how much of each one of them are present. So in this case, they're saying 8 grams of methane or CH4 reacts with 16 grams of O2. So they give you 8 grams of CH4 and 16 grams of O2, and then they're asking which is the limiting reactant. And again, please note, reactants are on the left hand side, so they're asking you whether CH4 is a limiting reactant or oxygen is a limiting reactant, right? Okay, so the way you do it, again, first thing you do is just copy this whole equation down here, and then you say, well, I've got 8 grams of this guy and 16 grams of this, right? So the first thing you do is you find the moles of CH4, right? Moles of CH4, and moles of CH4 would be equal to grams over formula weight, which is equal to 8 grams over the formula weight. Now formula weight of CH4 would be 12 for carbon and 4 times 1 4 for hydrogen. So 8 divided by 16 is 0.5 moles, right? Now this is the moles for CH4. Then you do the same thing for moles of oxygen, which is equal to grams over formula weight, which is 16 over the formula weight of oxygen, or O2, right? It is O is 16 and O2 would be 2 times 16 or 32, and the answer would be 0.5 moles of oxygen as well. Okay. Alright, so again, we were told that we had 8 grams of this guy and we had 16 grams of this guy, and then we converted this to moles and we found 0.5 moles of this, and we found 0.5 moles of this guy. Right, so to find the limiting reactant, you basically start off with this, the first reactant, which is 0.5 moles of CH4, and then you figure out how many moles of any one of the products would you get. So let's see, in this case I'm going to write how many moles of water can I get. So how many moles of H2O can I get, right? Again, the way we do it, we multiply this by a conversion factor. H2O is the required substance. We write H2O on top. CH4 is here. We put CH4 at the bottom, and then we look at the coefficients. We look at these coefficients in the balanced equation, and we find that you have it 2 H2O and you have 1 CH4, and this cancels and that cancels, and 0.5 times 2 becomes 1 mole of oxygen. We do the exact same thing for oxygen. We write 0.5 moles of O2, and we're going to find out how many moles of water. It has to be the same. It really has to be the same. Whatever you write here has to be the same as that. So I'm going to multiply this by a conversion factor, put H2O here. Okay, so you write H2O on top, and then oxygen, so you've got oxygen here, then you write O2 at the bottom, and then you look at the balanced equation. How many how many water? 2. And how many oxygen? 2. So I come back and I write 2 here and I write 2 here. This cancels and this cancels and this cancels and this cancels, and I would get 0.5 moles. Okay, so here's now the trick. You look at 0.5 moles of water and 1 mole of water. The reactant, right? The reactant, again, the reactant is either this or that. So the reactant, this or that. The reactant which gives you the least product, in this case oxygen, gives you 0.5. See, methane, CH4 gives you 1. Oxygen gives you 0.5. So the reactant that gives you the least product, that is the limiting reactant. And so we come here and say oxygen is the limiting reactant. Okay.